Well, we're almost there. So yeah, my name's Nicholas, and our goal at Nuventura is to make the use of sulfur hexafluoride, or SF6, obsolete in the energy industry. May I see a quick raise of hands for who knows what SF6 is? Does anybody know what SF? Okay, so we have a few people, very good. Well, I hope more of you will know what these are. Yes, they're shoes, but they're not just any shoes. They're actually quite iconic shoes. They're called Nike Airs, and they're often considered to be the original collector's items for what we call sneakerheads. But what a lot of people don't know about these shoes is that in the bubble under the heel, in the original models back in the 80s, SF6 was actually inside. But Nike soon realized that they were dealing with a very strong greenhouse gas and replaced it with nitrogen. As a matter of fact, SF6's use in pretty much every other industry has been phased out precisely because it's a strong greenhouse gas. But not only is it a strong greenhouse gas, it's actually the world's strongest greenhouse gas. So 1 kilogram of SF6 is equivalent to 23,500 kilograms of CO2. And its annual emissions, which are around 8,000 tons, are equivalent to the yearly CO2 emissions produced by around 100 million cars. And to make matters even worse, in a business-as-usual scenario, its use is actually expected to grow by 75% by 2030 from 2019 levels. And the reason for that growth can be found in the energy industry, where SF6 is used as an insulating medium for gas-insulated switchgear. Now, there's only a couple of things that you really need to know about switchgear. One is that they are extremely important components of all electricity grids. And two, their functionality is very similar to the functionality of switches that we will have in our homes for the lights. So their job is to turn off and on different sections of the electricity grid. Now, there's various different types of switchgear, but the one that we are focusing on is called Gas Insulated Switchgear, or GIS. And this is considered to be the premium technology, so the state-of-the-art in terms of switchgear. And the reason for that is that they allow for much more compact dimensions and also have a reputation for high reliability. So in essence, switchgear can be found throughout electricity infrastructure, from huge substations that you can see behind me to smaller compact stations that you can see closer to the consumer. You might have seen them out and about on the streets. However, SF6's use in the energy industry is attracting more and more attention from regulators, especially from the European Commission and also the California Air Resources Board in the United States. So much so that it's widely expected that these regulators will actually phase its use out in the energy sector by 2025. And it's for this reason that sustainable alternatives are urgently required. And that's where Nuventura comes in. So we've developed the first of its kind medium voltage gas insulated switchgear that replaces the SF6 with dry air. So that's basically just the air that we will breathe, except with the moisture just sucked out. And we've achieved this while not compromising on any of the benefits that I mentioned earlier. So that's compact dimensions and high reliability. In terms of our business model, we want to help the industry move as fast as possible away from the use of this gas. And with that in mind, we want to help switchgear manufacturers actually expand their own product portfolios with dry air alternatives. And to do this, we have two basically streams to our business model. One is called licensing, where we license the full design to switchgear manufacturers for them to build. And two, we can actually also sell core components to switchgear manufacturers for them to incorporate into their own switchgear designs. And then, of course, the manufacturers would sell the switchgear on to their own customers, which are generally utility companies and also industry. So this business model allows us, Nuventura, to focus on the R&D, which is what we do best, while allowing, as I said, the manufacturers to build on their relationships with their customers. So it's a win-win. In terms of the market, we're addressing a market of 23 billion euros. It's growing, and that's because of the energy transition, which is going to need a lot of switchgear, and also the increasing electrification of Asia and Africa. And in terms of our serviceable obtainable market, it's around 13 million euros. So how did we get to where we are today? So the project started in 2016. The first pilot of our prototype was installed with Westnet's Energy in 2018, and this was followed by the product's certification or type tests in Kima Labs, a prestigious German lab. And then we also closed our first customer, Dual ADE, a Canadian manufacturing company. And this was followed by a couple of more demonstration projects with E.ON Edis and also Arpex Energy, a hydrogen company. And in the coming months, we also hope to add to the list of demonstration projects with a Spanish project and an Austrian project, as well as add a Turkish manufacturing client. So in terms of financials, 2021 will close with a revenue of 428,000, but we hope this to increase, or expect this to increase by 2026 to around 13 million, with a nice EBITDA of 3.8 million. And we expect this financial success to also be accompanied by environmental impact, and that will be offsetting 814 kilotons of CO2 equivalent, which is the equivalent to the yearly CO2 emissions produced by around 460,000 cars. So our team is very experienced, with experience from McKinsey, Schneider, and ABB, and the money would be used to expand our team with a technical project manager to help with the existing projects and also the upcoming projects that I just mentioned. And so we hope that you will join us in our journey to give SF6 the Nike treatment and kick it out of our energy infrastructure. Thank you very much, and I look forward to your questions.